Welcome back. Um, the outline of the solution to problem 4, Thursday's problem, is given here. On the top right hand side we have the circle, which is the field with a fence around it that doesn't let in the donkey. The donkey is pinned at one point and the rope allows it eat an area that is schematically drawn with a red line. And what we're looking for is the length of this rope that will allow him eat an area that's half the area of the circle. Most of this area you can see is quite simple, and that's indicated by this blue vertical line here. Everything to the right hand side of that just constitutes half of a disk, half of a circle. So that area, A1, is just half pi r squared. Our real problem is finding the areas of the two hatched pieces. And the curve we're looking at here, or the properly drawn version of it, is called the involute of a circle. These two little bits are somewhat harder to work out and makes this problem a little more difficult than the Tuesday one where the poor donkey was inside in the field. And most of these problems where you find curves, especially interesting curves, you are better off to change to polar coordinate systems. And that's why I'm indicating here the simple schematic of the system. You can see the original x and y coordinates, and we're saying if we have a point xy, we can define it by a length continuing out from the center and a theta, which is an angle of rotation. Now, what do we do with that? Well, first off, what you have to find out is why we have a problem. Down the bottom right, you can see here part of the circular field, and the real issue is from the pin. You find that when the donkey heads towards point A, which is as far as he can go along the boundary, you'll notice that the rope is bent. Now that's why you get a curious shape in these two shaded areas, that the further it moves towards point A, the furthest point that it's able to get to along the fence, the less effective the length of the rope. Now, our xy point can be defined with a little bit of playing around as cos theta plus theta sine theta, and equivalently we have one for y. And a small amount of playing with both of those will tell us this: r equals the square root of 1 plus theta squared. Now, I know this is a little bit busy, this screen here, but I wanted to put it all on one screen for you. One other drawing that we have down here is at the middle, at the bottom. It's just showing you part of the circle, and by the way, we can rotate these drawings any way we like, and I've just rotated so that the bottom point here is now sitting on the horizontal x-axis, and you can see the curve moving up from it. The length r out to any given point, and we've got a small triangular wedge here. The delta area is half r d theta approximately. That then leads us to a little bit of integration for summing up in integration to find out the a of this one space. And we know when we find that one out, we will also have found out the area of this one, because the whole thing is symmetric about this line here. And when we work it out, we find that the combined areas of these two little pieces is r cubed divided by 3. It's simply integrate this equation over here. So the total area we know is to be half the area of the circle, which is then pi over 2, and it should be then equal to r squared outside of pi over 2 plus r over 3. That's an easy enough thing to work out, so that's been left here. Now there's an interesting point that comes out of this. If we give the donkey a rope that's just long enough, and we will show it here, just long enough starting there to go all the way around, that if he's eating along the edge until he gets exactly to the far side here. So the rope is now half the circumference of the circle. We will now get a bigger involute of this circle here. And what we find is that the area of this strange space that we have inside the red line, bounded between the red line and the circle, will be 5/6 the area of the circle. So that would be kind of the limiting condition, where both sides, because he can eat all the way down to here and he can eat across to here, and that's 5/6. Okay, enjoy the finished playing off of this particular one, and I'll see you tomorrow for the Fridays problem, which is very short but I think interesting. Goodbye now.